I know that it's quite a struggle starting to do the geometry. And I said to the Afrikaans class as well, we did 2 weeks, 2 weeks work we did in 3 days when we handled all 9 of the theorems. But the problem is if we take each theorem separately and we practice it, that's the way it's in the textbook. Then we're going to do theorem 1, practice, then 2 and up to 9. That will be 9 periods. Okay, it's 2 weeks. In the exams, you are not getting the theorems separately. You are getting them all at once. So by the time we are done practicing each one separately, we would have 3 days left to practice them all together, which would not be sufficient for us to be prepared for the exams. So yes, you are thrown in at the deep end. But I've said this yesterday as well. If you are not going to try, and in the Afrikaans class as well, I had time to check the homework. I don't have time to check your homework now. There are kids who aren't trying. You cannot figure out what you're missing if you didn't start looking for anything. Okay, so I'm going to show you how I would go about starting this sum. First of all, I definitely have drawn the sketch. Okay, because you cannot use colors in the textbook. Now I've decided this year all of the radius on my radii I'm going to make yellow. So looking at this sum, I'm not looking at what they're asking yet. I'm just indicating what I'm seeing with the information given, because they told me that O is the center. Now the moment that I did that, I hope that you all see that I now have an isosceles triangle right there. And I also have another isosceles triangle right there. They also told me in the information that AOB is a diameter. And a diameter cuts a circle in half, which means that this is also 90 degrees. Everything that I've shown, do you see it as well? Do you all see it? Okay. When I look at the sketch, I see that there are 4 points on the circumference, which indicates the cyclic quad. But it's not closed, it's the crisscross one. Now, when it's not closed, I can't use the opposite angles of a cyclic quad, because you see A is a closed angle, but there's not a closed angle at B. And the same with D and C. But when it's crisscross, I know that in fact this angle that I've shown you here, we said that C2 and 3 and B are the same size, no? Remember that, because of the isosceles triangle. This angle and this angle will be the same because of the crisscross. Do you see I already have 3 angles equal to each other? And the other crisscross will be with A2. That mom and dad is going to be C3. So not C2 and 3, just C3. I don't have, when I look at the center, I don't have theorem 1, where the line is perpendicular on a chord or bisecting a chord, so that one is out. I do have an angle at the center, which might also subtend the angle at the circumference. So I think there's one that we all can see pretty easy. And that's angle O1. That's the angle at the center, and then it will be linked to that angle D, that's the angle at the circumference. There's also another angle at the center that's a little bit harder to see. I don't know, maybe you didn't see it yesterday, but maybe you can see it now. Can you see the other angle at the center? What is it? it's O2 that will be linked to A1. So A1 is half of O2. D is half of O1. Do you see how much information I plotted down here? Just by looking at what do I have since I have a center, and what do I have since I have a cyclic quad. I haven't even started really with the triangles. I've indicated the isosceles triangles because of the radii. But I haven't used interior angles of a triangle and what. But it's all there because they are triangles. So once I've done that, I'm now going to start to solve the sum. They gave me the value of A2. They said it's 32 degrees. And they gave me the value of O1. It's 104 degrees. The first one they asked for was D. Do you see that D has been linked with B, with C2 and 3, and with O1? And the one I'm going to have to use, because I don't have those two, is O1. So I'm going to say that angle D is 52 degrees. Its angle at the center equal to 2 times angle at the circumference. Do you understand? Angle at the center equal 2 times angle at circumference. Right, now I want you to get into the habit of putting in the values of the angles that you have calculated, because that now helps us going further. Because the next one we now need is C3. C3. Now C3 and C2 together is linked to 52, but I don't want C2 and 3, I just want C3. But you will see there that C3 I have indicated with A2. Right? It's the cyclic quad one. So I can say that C3 is equal to 32 degrees, and my reason is angles in same circle segment. Angle B, and then what other angle? Then you only have that one, you need that one. And which triangle would you be working? Did you find this one first? So you had Jason there, and then that one, and then triangle. You'll have to come and show me. Okay? I'll have a look afterwards. You guys must also remember, and you can please do yourself a favor, and then you go and ask the grade 12Ds that have math. How much of a role does time play in geometry? So taking the long road can no longer be an option. This thing will count 1 mark. That's 1 minute that you have for that one. And that's very hard. That's very hard with the time. But that's part of it. So don't take long roads. That's why we indicate it beforehand. And that's why I don't even look at what they're asking. Because when you start looking at what they're asking, you're getting stressed out. Because you're not seeing everything. You're trying to see what they are asking for. And that makes trouble. Okay. The next one they asked for is A1. A1. Now A1 I've indicated with a dot with C1 because it's an isosceles triangle, angles opposite equal sides. and I have that angle that's 104. So I can say that A1 is equal to C1 is equal to, and I'm just doing the calculation in my head, 180 minus 104, and I divide it by 2, which gives me 38 degrees. And my reason will be angles opposite equal sides. Now, there needs to be something added to that, because did they tell you that that's an isosceles triangle? Now, I always say, if you think about my daughter Isabella, would she have known that's an isosceles triangle? How did you know it's an isosceles triangle? Because of the radii. Okay? So you're going to have to add radii to it, because it wasn't given that it's isosceles. The next one you need to find is C2. Now C2, I know, is part of B, and I know it's part of D, but I also know it's part of the 90 degrees. So there are many ways that you can do this now. But if I consider this, do you see that C1 that I have plus C2 that I want plus C3 that I have add up to 90 because of an angle in a semicircle? So I'm going to use that one. I say 90 minus the 32 of C3 minus the 38 of C1, which will give me 20 degrees angle in a semicircle. And there I have all of them proven. Alright, let's move on to the next one. What do I have in this one? I have a center. There are only 2 radii. Akuma? got isosceles. So I know B1, C1, they are equal to each other. Happy with that? Okay. Do you all see angle at center, angle at circumference? There's only one. Okay. Then they also told you in the information that BC is equal to CT. So put it on your, indicate it on your sketch if it's not been indicated. Now, this one has an influence. And I would immediately indicate it because we forget about it. Do you remember that angles in the same circle segment also has another name? Do you remember that? The other name is equal chords, equal angles. What are these two things? Equal chords. Therefore, they subtend equal angles. Those angles that they subtend must be on the circumference. Mustn't just be a random angle here in the middle of the circle. So that tells us that A1 and A2 are actually exactly the same size. Okay? Looking at this cyclic quad, because now I'm done with the circle and with those lines, there's no crisscross. So there's no angles in the same circle segment. We only use the equal chords, equal angle one. But when we have a cyclic quad, important to remember that we also have supplementary angles. But it's very difficult to indicate supplementary on a diagram or on a sketch. So what I usually do, and it's just personal preference, is I would write the T2 plus B1 and 2 equal to 180. Just to remember, maybe later I'm looking for T2, then I know I have it linked to something. And then also A1 and 2 plus C1 and 2 and 3 are also equal to 180 for the cyclic quad reason. Okay? So I'm just putting it there. Now the other thing I have here is the tangent. Now let's look at the tan chords. That tangent meets that chord there. Do you see it? This chord here. So an angle has been created. Which chord does that, which angle does that chord subtend? C3. So I therefore know those two are equal. Then there's another tan chord. It's T3. Which angle does that chord subtend? A2, and you see I also have information. So I know T3, A2 and A1 are equal to each other. And once I have A1, I also know that O1 will be double it. And when I have O1, I can find B1 and I can find C1 because they're equal, because they're in an isosceles triangle. And if I have all of those angles and I can find T2, T2 is linked to B1 and 2. And A1 and 2 is linked to C1, 2 and 3. So you see, I have a link with all of the angles to something else without knowing what they're asking. And was it difficult to do what I just did? Was it something that you don't know? No, we know it. I'm just checking, there is no radius on a tangent. Can you see that? Because then I would have to look for that theorem as well. Radius on tangent would be 90 degrees. There is only one tangent, there aren't two tangents. Okay. Right. Now, let's start. What they gave me is that this angle is 105. T2, I have it linked to B1 and 2. Okay. The other one they gave me is this one, 40 degrees. I have it linked to A1 and A2. So the first one that they're asking for is A2. Very easy. A2 is equal to 40 degrees. My reason is tan chord. The next one that they're asking for is A1. A1 is also equal to 40 degrees, but what do we call that one? Equal chords, equal angles. The next one they want is B1 and 2. Now I don't have a line through them, but do you see it's there? B1 and 2. B1 and 2 is supplementary with T2, and I have T2. So I can just say, right, B1 and 2 equal to 75 degrees. My reason is opposite angles of cyclic quad. What was the next one that I asked for? C2. C2. Okay. Now C2 is a very naughty one. Okay. I want you to remember, you cannot ever assume that this angle and this angle will be equal to each other. Okay. Never. I don't know what B2 is. So I cannot use interior angles of a triangle and like have that part of the angle and subtract it, because I don't know what B2 is, and B2 and C2 is, there's nothing to indicate that they are the same size. There are different ways that we can find it though. You can, for instance, find C3 with interior angles of a triangle. Do you agree with that? Or you can first find T1 with adjacent on a straight line and then find C3 with tan chord. Doesn't matter which way, but we can find C3. It is possible. We can find C1. We're going to have to find O1 first, and then we're going to find C1 with the isosceles. And once I have that C1 and I have C3, I can use opposite angles of a cyclic quad, because there's the C2 that I want. It's a long road, okay, but you can use it. So I'm going to start, I'm going to say C3 is equal to 35 degrees, and my reason will be interior angles of triangle. I think that's the shortest way to get it. To get to C1, I'm first going to have to find O1. It's going to be 80 degrees because it's angle at the center equal to angle at the circumference. Then I can find C1 equal to, I have to say 180 minus 80 divide by 2. C1 is 50 degrees, and its angles opposite equal sides. Was it given that that's an equal sides? Those two, is it given that they are equal? Would Isabella know it? No, so I have to say it's because of the radii. And now I know that C1 and 2 and 3 will be equal to, you see it's opposite from A1 and 2. It's going to be equal to 100 degrees because of opposite angles of cyclic quad. And now I'm just going to do a subtraction sum. So there's no reason. I say thus, C2 is equal to 15 degrees. So that one's got quite a long run. In an exam, they would have asked you to find maybe another angle beforehand. But please, very important, you cannot assume C2 and B2 are the same. That's just a quadrilateral, random quadrilateral, nothing special to it. Are you happy with that? Sure? Okay. The last one. The thing that's difficult about this last one is that there are two cyclic quads in that thing. Do you see that? There's a cyclic quad STVW, and then there's another cyclic quad STWQ. Right. Let's look at STVW. Is it crisscross? Is it crisscross? No. But they are opposite angles, so I'm going to make that note again. S1 plus V equal to 180. And then T1 and 2 plus W2 and 3 equal to 180. In the other cyclic quad, now I close this part just to help me see it. I know that T1 plus Q2 will be equal to 180. And I know that S1 and 2 plus W1 and 2 will be equal to 180. And then they have also thrown something into the mix here that we can remember from grade 8. But this one, oh, it mixes us up here in grade 11, the parallel lines. And normally in the first term, if we write on geometry in the first term, they have a parallel line in there and it catches us. So remember, parallel line, you look for alternate, you look for co-interior, you look for corresponding. Now looking at this, I hope you can all see there's no corresponding because the transversal is not extended past. But there are some alternate angles. So it's this one that's alternate to this one. There's not another one. Now let's go to the tangent. Some tan chords. There's an angle between the tangent and the chord. What is the angle that this chord subtends? S2. So therefore I know this one and this one will be the same. Right? Then there's the tangent and the chord SQ. Which angle does SQ subtend? SQ, W1. So this one and this one is equal and this one and this one is equal. They're all linked to each other. So the first one they are asking for is angle B. Right. Do you see there on my notes? I have S1 and S1 and V will be equal to 180. So I can just say V equal to 110 degrees, opposite angles of cyclic quad. Happy? The next one they're asking for is, what was it? Q1. Q1. Now you see Q1 I know is equal to W1. And W1 is equal to S1. So I'm first going to find W1. To 70 degrees, my reason is alternate angles. And then I can say that Q1 is also equal to 70 degrees and my reason is tan chord. Happy? Which one do we have to find next? T1. T1. Okay, T1. I see I have it there with the Q2. There's T1. But I don't have Q2. I don't have Q2. Can I find Q2? Yes, because I have this one is 70. So Q2, very easy, is equal to 80 degrees because it's adjacent angles on a straight line. And now that I have Q2, I can find T1. T1 is equal to 100 degrees because of opposite angles of cyclic quad. And then I had to find W2. W2, this one here. Now I just found T1 as 100. So very easy without putting a lot of effort into it. W1 will be 10 degrees with the interior angles of a triangle. it would mean that SQ would have to be parallel to WT. Can you see that? And they aren't parallel. It's these two that are parallel. After you've seen the way that I've done, do you think you will have an easier time doing it if you try it now again? So you see our method. Don't let the questions scare you. Don't let it confuse you. Start by indicating everything that you can. And then you go and look at the questions. Alright. So what I want you to do for tomorrow is on that same one, same activity, I want you to try questions 6 and 7. So it's page 237, page 237. You have to do 6 and 7. I only have Afrikaans, but I just want you to check question 6. They're asking you to show that O1 will be 128. Okay. So you don't use the 128. They just want you to get to the answer of 128. Do you get the difference? Okay. You can start with that now. I'm just going to stop the recording here.